Hello, everybody, and welcome. So this is really just a little brief short lecture to kind of focus us on what's important in the program in some sense, what's important in learning to program, and how to succeed. So let's proceed with that. We're going to talk a little bit about how you can succeed in this class and the things that you need to do to succeed. It's nothing very arduous. And then we're going to gain familiarity just a little bit with some problem-solving techniques that will help you as you move forward with this course material. One thing to remember about learning to program and learning computer engineering, if you tell someone something, if they watch you do something, you tend to remember it maybe until your next test and forget it. If I teach you something, and we talk about it a little bit, maybe you'll remember it. But if you're involved, if you actually do it, if you actually take part and you do the things yourself, you learn them, you internalize them, and you don't forget them. And we've known that for a very long time, and that's how we're going to proceed in this class. So how do you succeed? Learning to program a computer, solve problems, and program a computer and move forward in this field is really, it's not like taking maybe some sort of intro history class or something where you remember some dates and maybe you can talk about a little bit about what happened, maybe discuss it on some level. This is a really practical class. So this whole field is very practical. You have to do things. You have to know how to do things. So it's more like learning to play a sport. You have to get out there and swing the racket to learn to play tennis. You can't just watch somebody play tennis, and even if you watch them for 10,000 hours and know how to play tennis, you'll walk out on the court and you won't be able to do it. And it's just that way with what we're doing. You have to actually do this stuff. To start, you're just going to be typing things in. Just make sure you type them in so you get a feel for the language. You get a feel for the syntax, and you kind of internalize it and remember it so you don't have to look everything up all the time. If you cut and paste, you won't remember. So really to begin with, you need to be really writing things out. And there's a real sort of misunderstanding as well of what computer engineering, computer science, the whole field is. And most people think it's about programming. It's about writing computer programs. And sure, we do that. But the programming part is a tool. It's the tool we use to solve the problem. It's not really how we solve the problem. We solve the problem using other techniques and methods, and then we apply the best programming language for that particular problem. So there are hundreds of programming languages, and we use different ones for different things. You may not later on in your career, in your life, know the language that you're going to solve the problem with. And in fact, as time goes on, it's less and less likely that you will. It's less and less likely that you'll solve the problems in using exactly the same tools that you learn here. That's why what we're teaching you is how to solve problems, right? But we have to have a tool to start. We have to have a way to begin. We have to give you something. If you were an architect, right? Or you're in construction and you're going to build a house. Really kind of the first thing you have to learn is maybe how to use a hammer and hammer a nail. So if you don't understand that, you're never going to get your house built. So you need a tool. And we're going to give you the hammer, and we're going to show you how to hammer some nails. And then later on, we're going to show you how to build a wall. And then after that, we're going to show you, how to do the ceiling joists and all that kind of thing, right? We're going to eventually show you how to design that house. And it's the designing the house that we're getting to, but we have to learn all these intermediate steps. Even with AI, if you don't understand this, you don't understand the questions to ask. You don't understand the steps to solve the problem. You don't understand the prompts to give to figure out what it is that you need to do to get from A to B, to get from where you are to where you're going. So that's what we want to teach you here. And to do that, you have to do these beginning steps. Okay? So we're going to start with simple problems, show you how to find the solution, ask you to find the solution. to these problems. So there's a lot of work through it. We don't do a whole bunch of, here's exactly how you solve this thing, and now here, you just type it in like I typed it in. We'll start with that a little bit, but then we'll give you a problem, and you'll have to figure out how to solve it. So that's really kind of what this stuff's about. But don't worry. I mean, really, we do this. This is what we do for a living. So we understand how to get you from where you are to where you need to be. Just do as we ask. Type things in. Don't cut and paste. Don't use ChatGPT. In this course, using ChatGPT is cheating. And maybe another course, you'll actually connect to ChatGPT and use it for things. But now it's cheating. You have to learn these basics on your own so you know enough to do that other stuff later. Okay? And then, how do you do that? Well, follow along with instructor materials. Like if there are PowerPoints or instructor videos, or maybe videos of PowerPoints, or maybe videos of an instructor coding, I suggest that you kind of put that on one screen and then you open up another computer screen and then you follow along and kind of type it in with the instructor. Also in this course, we're going to use a Zybook. And, the Zybook is really kind of like a lab manual. You'll get a reading assignment. That's maybe a little bit of a misnamed. What it means is go through the Zybook unit and do the assigned exercises in the unit as you go. There are these participation exercises, and we'll talk about that more later, but you get points for those. So there's not a lot of reading, it's a lot of doing. The whole class, a lot of this class is like a lab, and you're just doing things constantly, and that's how you learn here. And as I said, don't cut and paste things. Type things in yourself. You learn the grammar of the language. You learn the feel of it. You learn how to do that. And remember, watching doesn't help. You have to write this code to learn how to do it. Okay. Sometimes as we move through the course or the course after this one and so on, or another course, you'll see code on the internet. And it's like, it may be tempting to go out there and grab that piece of code and plug it in. I wouldn't suggest that. One, your instructor can kind of tell because they know where you are and they know your coding ability, and they'll know maybe if there's something in there too complex for you to have done. The other thing is you introduce errors and you have to debug that code. And you spend a whole lot of time debugging the code. And what you'll end up doing is making this course much more frustrating than it needs to be if you just follow the steps that we outline and do the problems we give you, because they're timed for your ability. And so that's really what we want to do. And then there's the cheating and plagiarism part. So in this course, using ChatGPT to write your code or going grabbing code off the internet and that kind of thing, that's considered plagiarism and cheating. So please don't do that. That isn't to say that there aren't resources you can use. So if you see the link to W3 Schools there, you can always type that into Google, W3 Schools Java tutorial, and go in there on the internet into that website. It's a free website. It's got a Java tutorial with real simple problems, and it's sort of like your Zybook, only at a lower level. And you can follow along and help figure out how to do something. But they also have examples, and they have the syntax or how something is written. So if you want to look something up real fast and you don't want to look through the book or back through the chapter, you just want to kind of Google it real fast when you're really not Googling, go to W3 Schools Java tutorial and just search for the thing that you're looking for. Like if you wanted to know how to do a while loop, you'll understand what that is later. If you want to know how to do a while loop, for example, how to type it in, you could go there real fast and find it. Okay, so it's a useful tool for you at this point. So how are we going to go through the class? Well, I'm going to give you an in-depth video about how we move through this course, but just in general, there are modules, and each module will contain instructions about what to do in that module. But overall, you're going to watch instructor lectures. You're going to do the reading assignment in the Zybook. It has participation activities. You'll do those activities and gain points as you move through the unit. Then there will be maybe another homework assignment, which might be challenge activities in the Zybook, or those may be incorporated into the reading assignment. It just depends. And then there will be a lab assignment in this course. And the lab assignment is where you have problems that you need to write code to complete. And those are generally due on a weekly basis. There's a lot of work in this course. There's a lot of coding, a lot of typing things in. This isn't something that you just sort of watch some videos or fool around for a week and then on the weekend you sit down and try to do it all. You really need to work on it every day. You need to set aside time every day. If you started on Monday, for example, before the weekend, you should really be done with all of your reading assignment and probably homework assignment. And the lab assignments, you should leave us 2 or 3 days, probably three days at least to do those lab assignments. And you can start those earlier. And I suggest the earlier you begin this stuff, the better. Because if you wait to the last minute, you might not get it in on time. And these deadlines are pretty firm in this course, and so you don't get points if you turn things in late. There's also no time to ask questions. So you really want to, if you run into something and you get stuck, and you will, you'll write a program, it'll have a bug, you can't figure it out, you go back and you look at it again. It helps to look at it the second day, not right then, rest your brain and come back and look at it again. That sort of thing. Or if you need to ask the instructor a question because you're stuck on something and just can't move forward, there has to be time for that, him to respond or her to respond to you. And that means you need to be working on these things earlier in the week if possible, as soon as you can, so that you have time to move through this. Otherwise, if you do it at the last minute, this can be a really frustrating experience. If you start early, it's fun. Okay. A second monitor really helps. Okay. So if you have a second video screen or something that you can look at while you do something on your computer, that's incredibly helpful. If you can always put something on your phone and watch it while you're typing on your computer. You can put the assignment that you're working on your phone, so you can see the steps in your assignment while you're actually working on it on your computer. You can split the screen. A lot of students do that. They'll put the assignment on one half of the screen and the workspace where they're working, and we'll talk about that later, but the workspace area is called an IDE. They'll put that on the other side of the screen and they'll be in there working on it. So 2 screens helps. Okay, and I would really suggest that you do that, because that also makes the course less frustrating. It's not something you have to have, but it's helpful. Okay, now, all that said, computer science, computer engineering, it's no more about computers than astronomy is about telescopes. Same thing I was talking about a minute ago. Astronomy is the study of the heaven. The telescope is the tool. The computer is the tool. The computer language that you're programming in, that's the tool. What we're really doing is solving these problems, okay? So how do we do that? Well, the purpose of writing a computer program is a list of steps. It's like, do this, do this, do this, do this, do this. We're telling the computer what to do. And the purpose of writing that program in a programming, whatever the programming language is, we call it coding. The purpose of that is to solve problems. Computer science is about problem solving. In Europe, they don't call it computer science. They call it informatics. I kind of think it ought to be called algorithmics, because what we're really doing is we're studying that series of steps that's necessary to get this thing solved. Okay? But it's all about taking this challenging problem that someone gives you, finding a plan to solve it, and then moving ahead, and then kind of reiterating and doing it again, basically just figuring it out on your own, figuring out a good path, trying it. If it didn't work, okay, we're going to back up and fix it a little bit. Now we're going to try again. It's all about trying and doing over and over until you get it done. There's this iteration process. You don't sit down and do something and it's done and get up and walk away. You sit down and you work with it for sometimes a long period of time until you get it right. And you can get lost in that process. You can get into flow. It's like playing a sport. And sometimes athletes talk about sort of time slowing down, and they lose the passage of time, and time has passed and they don't even realize it. If you give yourself time to do these problems, so you're not worried about the clock, and you sit down and you're working through this stuff, you just kind of relax, and you're working with the computer back and forth, trying to get this to work. You can lose yourself, and you'll look up and it's 4 hours later and you don't know what happened, and it's very, very, it gives you a real kick when you finally solve it and it's done. It can be a really kind of, the challenge is there, and you solve the challenge, and It's just can be very exciting for you, if you can relax into it and you're not pressured with this big worry that you got to get it done by now. So start early, okay? That's very helpful. Solving a problem really consists of multiple steps. Now, at the beginning, a lot of students, a lot of people, they start by looking at the problem and then trying to implement the solution, and they just start trying stuff. Now, that's a good way to waste a lot of time, and it's a good way to frustrate yourself. And eventually, students learn, well, wait a minute, maybe I should have thought this through a little bit before I started typing out all the code, right? And you should. So there are really a sort of simple series of steps, and you can make this more complicated, and we'll dive into it later in some other classes and so on. But basically, just really understand the problem. Understand what's being asked and what the series of steps are that are at least being given to you to start with. What does this actually mean? And then think about what are the steps that I need to do? What are the intermediate steps in solving this problem? Don't worry if you can do them yet. Just figure out what those steps are. And then you're going to kind of break those steps down into further down into steps until you have a series of simple steps for solving the problem. And in fact, this really works for life. If you have an overwhelming problem that's facing you, break it down into smaller steps that need to be done to solve it. And then break those down into smaller steps and break those down into smaller steps. And pretty soon you have this kind of long list of steps, but each step is pretty simple. So you know that if you do these things, it's going to get solved. And so maybe, you have this life problem and you break it down into 10-minute blocks per day, and you know that in a month and a half you're going to be done and it's going to be solved. And that's a really good way to approach things. And that's how we do it with computer science. Because if you think of the whole big thing and now how do I solve this all as one block, that's scary and hard to do. But if you break it up into these, simpler steps and break those up into simpler steps and so on, it makes it much easier. So you kind of do that, design your solution. And then, you start working through it. Maybe you run into some problems, or you get partway through and you're thinking, well, maybe I need to do it a little bit differently. You go back and you redesign a little bit and you keep going, okay? But you do it from the top down. You do it from looking at the whole problem and where you need to start and where you need to get to. You don't start by working on the little bitty things unless you just want to do some little experiment to learn something, right? You look at it top down. Then you implement the solution, and then you check it to make sure it really is outputting the information or the solution that you want it to, okay? So that's really what we want you to do. Even with the simplest problems, start with that. Understand the problem. Think about how you're going to do the solution. Give it a shot. Put it into some code. Think about it. Does it work? Go back and refine it a little bit. What did I do? What needs to be done a little bit differently to get from A to B? But always keep that overweening thing. You're going point A to point B. Don't get lost in the trees, right? Okay. So we look at these things from this top-down perspective, never bottom-up. So we want to break it into these big steps. In terms of a computer program, we look at the inputs to the program. In other words, what do we know, or what is the user going to type in, or what buttons are the user going to click, or that sort of thing, And then the outputs. What does the program do that transforms that input into some kind of output that the user needs, right? So if you're buying something online, your input is dragging things over and dropping them in your shopping cart, and then you click the button that says, um, buy these things, and it calculates the total, shows you how much it costs and all that, and sets up your purchase. So that the input and the output. And of course, that's a complicated program. It's much more complex than something we would work on here at the beginning, but that's the general idea, right? You put yourself always in the user's shoes. What do they see and what do they do at each step? Okay? And that'll keep you out of trouble. This is a hierarchy chart. It's a tool for doing that. It's a tool for solving problems that way, kind of the way that we just discussed in a top-down manner. So if you look at this, the top level is generate the payroll. So the idea is that we're going to to produce our payroll, our paychecks for our organization. So really there are sort of three parts to that. And the three parts are we need to get the payroll record. So, we need to look at how much people worked, how many hours, what they get paid and all that, or at least how much they worked. And then the next step is we're going to calculate their pay. So we need to calculate their gross pay. What do we owe them for those hours? Any deductions, for taxes and so on and so forth. And then we're going to print the paychecks. Well, each of these intermediate steps, get the payroll record, also has some steps. Calculating net pay means we need to calculate their gross pay from their hours that they worked, then calculate what the deductions are, and then update, that information. And then to calculate the deductions, there are even more steps. Calculate the tax withheld and calculate the Social Security withheld. And then, we're going to print the check. So the real steps to solving this big problem are read the payroll record, validate the payroll record, calculate the gross pay, calculate the tax withheld, calculate the Social Security withheld, update the employee record, and print the check. So you see, we started with this big problem, generate payroll, but we've broken it down into these intermediate steps. And that's really the best way to kind of proceed as you do this. We have some tools. So the tool that we're going to use in this class is Java. Java is a programming language. And it's an object-oriented programming language. So it allows you to organize your code, your programming, into these blocks or modules called objects. And the idea is that this is a way of thinking. What we do is we think about the entities in the program, the things that the program is made of, and we write a class or object. We start out writing classes, and they're turned into objects. We write those about each of those entities or concepts or ideas. So, for example, if we have a school situation, a college situation, there are certain entities involved. We have students, we have courses, we have, where they charge you, all that kind of stuff. So for example, we might have an object in our code. We might write a class or object that represents a student. And that object would include various attributes or variables that represent the student, like maybe the number of hours that a student has accumulated, course hours, the GPA of the student. It might have student's phone number. It might have a picture of the student, all that kind of stuff. Those are attributes, and they're all connected with a student object. And we can instantiate many objects, all exactly the same, but all containing different data for each student. So each student is represented in our code by this object. And we can make lists of those objects or lists of those students and things like that. I'm not trying to objectify students, okay? but that's the terminology that we use for entities in our program. Another object might be a particular course. And that course would be an object, and it would include a class roster of students. So see, we break things up into these objects and our so-called classes. We write a class and we create an object from the class. So that's kind of how it works. We're not going to get into that deeply right here at this second, and it's not going to come into the course for a while, but that's the way we think about it, okay? And that's called object-oriented programming. It allows us to solve problems efficiently by breaking them into blocks. So that's sort of where we're headed. That just gives you an idea of where we're going, okay? Classes are a kind of template. And so when you write a class, that class is going to be converted into an object when we actually run our program, okay? And the class has methods, behaviors, things like that. You're going to see all that later. We're not going to have to go into any detail with that right now. And it's okay if you don't understand it. Just giving you a sort of a taste, an overview of where we're going. So don't get nervous about it. We're going to talk all about that. You'll know it all by the time we get there. Okay? So we'll talk about these concepts as we move forward and learn to solve problems using the Java programming language. Now, there are a couple other programming languages out there. There's one called JavaScript. JavaScript and Java are completely different. They're two different languages, okay? So we're looking at Java, the Java programming language. All right. So the things that we've talked about here, we talked about how to succeed by writing things out and typing them on your own and not cutting and pasting and that sort of thing, by following along kind of and trying things with videos and other resources. Be sure and type things in and do the participation activities as you move forward, because this is all about building a skill set, and you have to do it to build that skill set. And what we're really going for, in addition to learning Java and learning to use that particular tool, is solving problems. We're learning to solve problems as we do this. So you'll be presented with little problems and you need to work on them and kind of try to figure them out and figure out how to solve them. And it's just like building any other muscle in your body. The more you do it, the more you can do it. If you don't do it, and you try to look it up all the time and just, figure out where somebody else has solved it and copy their solution, and don't try to work through it on your own, you won't grow that skill set, and later on it'll be harder for you. Okay, just remember, when you have big problems, you want to break them into smaller blocks, and break those into smaller blocks until you have a set of steps. Okay, with Java, we're going to break problems into objects that represent sort of the entities that we're dealing with in our code. And that helps us organize and solve problems. Really, the second course is even more into that. Sort of, we'll get deep into that toward the end of this course, and then more so in 605, the second Java course. Okay? All right. So that's kind of a general idea about how to proceed. So let's get started and do some of this stuff. Okay? All right.